Welcome back to a new data science project. In this video, we are going to do a complete data science project. We are going to do data cleaning, data analysis, data visualization, feature engineering. We are going to train machine learning models, and then we are going to create a simulate web app for getting predictions from our machine learning model. I will be adding the datasets link in the description of this video. Let's start coding. This is the Kaggle page of the dataset that we are going to be using in this video. Our dataset is about real estate, and we have the data about USA, and we can see that real estate listings in the US broken by state and zip code. So let's take a look at our data card, and then in the coding part we are going to talk about our data more. So context: this dataset provides information on real estate listings across the United States broken down by state and zip code. It includes a variety of details about each property, such as the price, size, and location. This data can be useful for analyzing trends in the housing market, understanding regional differences, and exploring patterns in real estate price. So, let's take a look at what we have in here. So, in here we have 12 columns, and I'm going to expand this like this, and let's take a look at our columns. So we have broker agency encoded, property sale status, house price, number of bedroom, number of bathroom, total land size, lot size, and address, street address encoded, name of the city, name of the state, zip code, house size, living space in square feet, previously sold date. Okay, so we have a dataset like this, and we can see the CSV file in here. I'm going to leave this Kaggle page link in the description of this video. If you want to code with me in this video, you need to get to this website and then press this download button. After pressing this button, you are going to have the CSV file, and when you put that CSV file in the same destination with your Python scripts, then we will be ready to go. I'm going to be downloading the dataset, adding into the folder that I will be running my Python code, then I will be re-recording at the code editor. I'm in Visual Studio Code. You can use any code editor that you want. My favorite is Visual Studio Code, so I will be using that in the video. But you can use PyCharm, Google Colab. It's completely up to you, and it doesn't matter. So I'm going to close this welcome page, and then I'm going to open the Explorer for creating a file named analysis and modeling.ipmb. And next, by the way, I saved the data link in here. I will be leaving this in the description for sure. If you want to code with me in the video, you can download this dataset. Also, I put the CSV file in here, so we are ready to work with it. So I created a Jupyter notebook. Now I'm going to select my kernel, like 3.11.4 Python. Now I will say import pandas as PD. Then I'm going to say pandas read CSV, and I'm going to get this dataset name, copy, then I will be editing here, then I'm going to make this run, and we are going to see that our data is loading successfully. So I'm going to save it as data, and from now on, when I call data, we are going to have that dataset. Also, we can use like head like this, or tail for seeing the last rows. Head returns the first 5 rows, tail returns the last 5 rows. Also, you can specify the number of rows that you want to see. Like defaultly, they are both 5, but if you say head 3, you are going to see the top 3 rows. If you say head 20, you are going to see the top 20 rows. I will leave it for as 5 defaultly for checking our data. Same applies for the tail too. You can say 3, 20, 5. It's completely up to you, but I will check the first rows, and let's talk about it. So we have both integers and strings. We can see that at the broke by we have encoded floats like for sale, strings. At the status side, price side, we have floats, bed, bath, acre load, street, city, state, zip code, house size, and previous sold date. So it's looking pretty nice. Now what I'm going to do is I will call data.info, and we can see the range index in here, also the data types of the columns, and we have the float of 8 in 4 objects. Great. So next I want to go by calling data.describe for getting the numerical summaries of the integer or float columns. It shows it in the scientific format and we can see our range from here. Now what I want to do is, firstly, I'm going to drop the NA values, but what we need to do is we need to remove this column completely, because I'm going to say is NA.sum, and in here we see that we have a lot of NA values, and it's not important to have NA values on the brokered by or previous sold date, but if I say drop NA right now, it's going to drop that columns too, so I don't want that. What I'm going to do basically is I will say data drop, and I'm going to specify the columns that I don't want. I don't want brokered by. Actually, let me check, we can drop more. I don't want status, or maybe status can stay. I don't want city, I'm not going to use that. Maybe we can use that. Maybe we can use that on analysis, so I'm going to leave it. So I don't want zip code 100% and previous sold date. So I will say zip code and I will say previous sold date, and when I make it run, it's going to return me a data frame without the columns that I wanted. So when I call the data again, I'm not going to have that data frame because I didn't set this and modify the original data frame. We can modify the original data frame in two ways. I can set this to something like data again, or we can simply use in place. This is what I'm going to do. In place equals to true, and I'm going to set this, and when I call the data, we are going to have the data frame we want. So great, we don't have that columns. Also, I want to check the shape. Also, we can see from here what I want to apply this. We have crazy amount of rows, like real big data set, and 9 columns. So we checked for the NA values, but we didn't do any operation. So I will say data is NA, and this returns cell-wise booleans, and if you say sum, you see column-wise, and if you say sum again, you will see the total amount of NA values. Now I'm going to drop them. I will say data drop NA like this, but same applies. We didn't modify the original data frame in here. For doing that, we need to specify like in place true again. And now if we call data is NA sum with sum, we are going to get 0. Great. So I will call data head for the next operations. Let's check for the duplicates. For that, we will say data duplicated like this. And we can see we get booleans for every row. We can use sum. And we can see that we have 535 duplicates in our data. So let's remove them. We will say drop duplicates. And again, we need to specify like in place equals to true. With that, we are not going to have any kind of duplicates. Data duplicated sum. It's 0. Great. So I will call data again. Let's check the value counts for the status side. I will say data status that value counts, and it's, by the way, how many data points we have left. Let me check. It's around 1 million. Okay, so they are like similar. There is no big difference on this side, and also we can check like all the values in here. I'm curious about the states, so I will say data state, and I will use value counts in here too, and I get a crazy result. So let's modify this, like it's sorted in default, but you can use sort values like this, and you can say ascending true if you want to see in the ascending order. Like this returns this value counts and group bys all return pandas series, and you can use the pandas series attributes with them. Like you can plot this information, you can manipulate it, like you can use that head for seeing the top 5 rows, like the first 5 rows. I'm going to make it run, and here is our result. We can do any kind of manipulation on there that we can apply on pandas series. And what I'm going to do is I will say false in here, and I want to create a bar plot of the top 10. So I'm going to say that head 10, and I'm going to have that. Now I will say that plot on this series, and I'm going to specify the kind as bar. And we can see our bar plot, but we can make it prettier, like we don't have title, Y label, and our X label is lowercase lettered. So let's fix that. So for that, I will call import matplotlib.pyplot as plt, and now we are going to make our plot look prettier with matplotlib. So I will say plt.title, and I'm going to add a title like, let's say, state counts of data, and maybe we can change that like state number of houses by state, and I will give the Y label like number, and let's say like listing number, and X label like state. Then I will use plt.show at the end for making this thing disappear. And here is our result. As I said, we can manipulate this panda series, which returns from here. Okay, so I will call the data again, and let's do some group bys. Like, let's group our data by state and then price. So for that, I will say data group by. I'm going to group by state, and I will take the values of price. So I will do this, and I will use .sum. Actually, I will use .mean instead of sum, because we are not going to take the sum, and we can do like sort values ascending false for finding the most highly priced states. And then what I'm going to do is I will say as type integer, and we can see we don't have any scientific numbers anymore, and the leading one is the Virgin Islands and the last one is Ohio. So let's also group our data by city, and then I'm going to show you how we can do like state and city multi-index group by. So for the group by side, I will say city, and then I'm going to take the values of price. I will use mean. Then I will say ascending. Actually, on the sort value side, I will say ascending equals to false. Now what I'm going to do is I will say as type integer, and we can see that highest one is international and the last one is the pilot mount. So what if we want to do a multi-index group by? We can say data group by, and in multi-index group by we firstly need to give list, like we are going to firstly group by state, then city, and we are going to take the values of price, and we will take the mean, and we are going to have something like this as result. And if you want to get this information as pandas data frame, we can do reset index, and now we are going to have a pandas data frame. Like we had the states Alabama, Abbeville, Alabama, Adamsville, Alabama, Edison, and we have values like that. Okay, it's cool. Now I'm going to call the data again, and what I'm going to do is I'm going to calculate the correlations with the price column. Like I will say data frame, and I'm going to say select data types. Actually, I will say data, select data types, and I will say include number. So it's going to return me the columns that has only numbers, but I need to say include, and here it is. So now what I'm going to do is I'm going to say dot correlation, and we are going to get the correlations, and I'm going to take the price from here like this, and here is our price correlation. So it makes sense, if bed increases the price is going to increase. By the way, correlation takes values between 1 and -1, and 1 means strong positive relationship, -1 means strong negative relationship. In correlation of 1, the prices or the values move together. Like if one is increasing, the other one is going to be increasing too, and if one is decreasing, the other one is going to be decreasing too. And in strong negative correlation -1 scenario, we have negative directions. Like if one is increasing, the other one is going to decrease, and if one is decreasing, then the other one is going to increase. So in the bad side we see a positive correlation. It's not really strong, like it's close to zero, but bad amount, which bad stands for bedroom, increases the price, bathroom increases the price, agri-lot increases the price, street, actually it's encoded, so it's not necessary, it doesn't make any sense, and at the house size it increases price. So they are all logical, great. Now we can start to modeling. So I will call data again, and in here what I'm going to do is I will say X is going to be our predictors. I will pick, let's say I want to include bed, I want to include bathroom count, I want to include house size, and I think they are enough. And next at the Y side I'm going to include data price like this. And now I'm going to call the X and I'm going to call the Y. We have values like this. Now we can keep moving. So as the next step, I'm going to train a linear regression model. So I'm going to scale my data. If you are going to train any type of tree-based model, then you don't need to scale your data, but in here I'm going to scale my data. Also, I'm going to export the scaler since I'm going to be using the same scaler in the web app creation part. So I firstly need to note them, like the order of the columns. I will say x.columns, and I'm going to take this order and I'm going to create the app.py from now, like it's going to be our Streamlit app place, and I want to put it like this because we are going to take the input and pass this input in this order to model. So it's really important. I'm going to keep that in here. And next what we are going to do is I'm going to do train test split. So for that I will say from scikit-learn.model selection import train test split, and we are going to do our split like x train, x test, y train, and y test. We will use train test split. We will give x, y, and with the test size 0.2. Actually it's test size. And next what I'm going to do is, by the way, we use train test split because we evaluate our model with the testing set and we train our model with the training set. So we are evaluating its performance with the unseen data, which is going to be our test. And by setting test size as 0.2, we specify that 20% of our data is going to be at the Y and 80% is going to be at the training set. 20% on the test set and 80% in the training set, not Y. I said it wrongly. And we can also check from length, like I'm picking something. Let's check the Y's. Y train and Y test, it's going to be a small number. Yeah, okay, so what I'm going to do right now is I'm going to scale my X features since we have really different values in here. Like in bed size, we have 3, 2, and 920. Bath house size, like this house size is too large that it can affect the model too much, and bed and bath can affect less. So what I'm going to do is I will say from scikit-learn import preprocessing, and then I'm going to say label encoder, not label encoder, scalar, standard scalar, and I'm going to initialize my standard scalar like that. Actually I'm going to make different imports. I confused, like I think we are going to do encoding, we are not going to do. So from scikit-learn preprocessing import standard scalar, and in here now I'm going to initialize it. Then as the next step I will say xtrain, and xtrain from now on is going to be scalar fit transform xtrain. So I'm going to show you the xtrain values before this operation like this, and not that, actually we can check the actual values and xtrain values after this operation. Like I'm going to make this run, I'm going to make this run, and now I'm going to make this run. So we have an array like this. At the xtrain side we are going to do the same for the xtest, but before that we are going to export our scalar because we don't want to have data leakage. So I will say import joblib, and I'm going to export my scalar like joblib.dump, and I'm going to say scalar is going to be exported like scalar.pickle, and we can see our scalar.pickle in here right now at the Explorer site. And as the next step, we are going to scale our xtest, like I will say xtest is going to be scalar.fit transform, and we are going to export the xtest like this. Not export, scale. And now we are ready to train our model. For training, we will say from scikit-learn.linear model import linear regression, and then we are going to initialize the linear regression like linear regression. We are going to fit it like linear regression.fit xtrain with ytrain, and we are training our model in here. Now I'm going to take predictions using xtest, like our model is going to predict the y-test values using xtest, and we are going to store them in something like predictions, and we can calculate the performance like I'm going to say from scikit-learn.metrics import mean absolute error, and I will call mean absolute error with y-test and predictions. So it's going to compare, and this is the value we get. Actually, it's good or bad. Decision is completely up to your case. Like I will call data, then I'm going to select the price, then I will say describe, and I'm going to say as type integer. You can evaluate if it's good or bad based on this value. Like we have this value, it's smaller than mean, etc. You can do any type of analysis like that. I'm not going to do, I just want to show you how you can evaluate that. And now what I'm going to do is I'm going to export this model. So I will say joblib.dump, and I'm going to take the thing that I initialized in here, linear regression, and I will export it like model.pickle. And now we can see it in the Explorer. Now I'm going to save my notebook, and let's summarize what we did in the notebook, and then we can start to create our Streamlit user interface app. So from starting, we read our data, we check the general information, we did analysis, we dropped the columns that we want, because if we say drop NA with the other columns, we can lose important information, it's unnecessary. We checked for the NA values, dropped them, we checked for the duplicates, we dropped them. Then I take the value counts on the status, we checked, we created a bar plot, then we made some group bys, and next we take a look at the correlations, and they are all making sense. We picked X and Y, we saved the X order in our app.py file. It's really important because we are going to give the model in the same order, and we did train test split. After that we did the scaling operation because we don't want data leakage. We imported standard scalar, we scaled our data, we exported the training scalar in here, and then we scaled the xtest, and next we fitted our model, we checked its mean absolute error, and we exported it using joblib.dump. And now we can close our notebook file and create our machine learning web app. We are going to start with importing Streamlit. We are going to create our app with it. We are going to import Streamlit. Then we are going to import NumPy as MP for the array operations, and we are going to import joblib for loading our scalar and model. Let's start by loading our scalar. Like for that, I will say scalar is going to be joblib.load, and we are going to give the name of our scalar. I'm going to copy that. I'm going to paste it in here, scalar.pickle, and for the model side, we will say joblib.load. I will say, let me check the name of it, model.pickle. So we have our model and scalar loaded. Now what I'm going to do is I'm going to give a title like, actually I need to import Streamlit as st. Now it's going to work. I will say real estate price prediction app, and then I'm going to use divider. I use them a lot because I think that they make apps look prettier. And then I'm going to take my inputs, like for the bet size I will say like streamlit the number input, and I'm going to give something like enter the number of bedrooms, and I'm going to specify the value like 2 and step as 1. And at the bathroom side we can do number input, enter the bathroom, number of bathroom, and then I'm going to say value is going to be defaultly 1 and step is going to be 1. Next I'm going to take the house size, like size is going to be streamlit number input. I will say enter the size and value is going to be around something 1000 and step is going to be 50 this time. And next what I'm going to do is I'm going to collect them in something like X, and it's going to be bed, bath and size in the order that we created our X. So now we can delete this, and next what we are going to do is we are going to define a button. But firstly let's add a divider. I'm going to define a button like predict, and it's going to be streamlit button, and we will say please press the button for prediction, or maybe go with something shorter, we can say predict, and then we will say divider if predict button gets used, and I will firstly write the else it's not used, we will say please use the button for prediction. And if the predict button gets used, then we will say x1 is going to be numpy array, we are going to turn our x in array. Then I will say x array is going to be scalar.transform, we are going to use the scalar in here, and we are going to transform our x1, but I will add brackets since our model expects inputs in two-dimensional format, and at the prediction side I will say model.predict, and I will say, actually let's change the name of this like predict button, and we can do like predict button, and I will say model.predict. What I'm going to do in here is I will say x array, I will give my two-dimensional array, and I'm going to take the first value from here. And next I will use streamlit.write. I will say the prediction is, and for making it look prettier I will say prediction, then I will say like float like this. Also we can add effect like streamlit.balloons. If the button applies, it's going to be showing a little animation. And now I'm going to save my file. It's this. I think it's going to work smoothly. Let's test it out together. What I'm going to do is, after saving this, I'm going to go to the terminal and I will say streamlit run app.py. And I'm on my browser right now. A screen opened up. If it didn't open up, you can follow this local URL. You just need to copy that and enter that in the browser, like from on the search bar, and you need to press the enter. Then you are going to go to your app site. Let's check how our app is working. So here is our app, real estate price prediction app. We can see our inputs are in here, and we have the predict button, and we have the text of please use the button for prediction, and let's use that. So it says streamlit has no attribute balloons. So I think I'm missing an O. I'm just going to change that and save my file again. I will say balloons this time. And now I'm going to save that, and I'm also going to show you what I changed. Here I changed balloons to balloons. I made a typo. Now in here I'm going to use the predict button again, and we can get our prediction smoothly. So I'm going to change these numbers, like let's say number of bathroom 2, and enter the size of let's say 2000, and now we have this prediction. I'm going to decrease these numbers, like I will say 1000 in let's say 900, and we are going to get a prediction. Also you can change the theme, like you can come to the settings, you can apply anything that you want, you can make it light. I don't prefer the light, I'm going to go back to the dark, and we see that our machine learning web app is working nicely and we can use that. So I'm going to go back to the VS Code and summarize what we did in the Streamlit app creation part, and then it's going to be end of our project. So let's try it again with like 3 and we get the estimation of this. Great. So we import Streamlit for the web app, NumPy for the array operations, joblib for loading our scalar and model, and then we load our model with scalar in here. Then we give our app a title, we use divider, we take our inputs from user, and this is important. We create the X with the same order we have in the model training. Then we define a predict button, and if the button applies, we are going to make this run. If it's not clicked, we are going to make this run. And in here we display balloons. Then we create an array on X1, and then we use our scalar for transforming our features. Then we use model.predict xArray, and we take the first of it. Then we write our prediction into the app. And this is all for this project. Thanks for watching. I have a data science projects playlist where I have more than 30 projects like this. You can check that playlist from the cards of this video. Also, I'm sharing a new data science video every week. You can subscribe to my channel for more videos like this. Let's get to the outro. Thanks for watching this data science project. I have a data science projects playlist where I have 40 projects just like this one. You can check that playlist from the cards of this video. Also, I'm sharing a new data science video every week on my channel. You can subscribe for more. Have a great day.